Welcome everybody to another episode of React Roundup. I am TJ Van Tol, and joining me today is Robin Pokorny, and hopefully I pronounced that last name correctly. So could you just introduce yourself, tell us a little bit about what you do, what makes you famous, that sort of thing?
Hi, thanks for having me here. You said the name very well. So I am a developer based in Berlin, Germany. Originally, I'm from the Czech Republic, which is a neighborhood country. By the way, these are the two countries with the highest beer consumption in the world. Coincidence, I guess. And I've been interested in functional programming, especially writing functional code using TypeScript, because TypeScript is now the lingua franca of JavaScript development in a way. And I really like the functional programming ways of programming. And TypeScript isn't by default, it doesn't support it well. So you have to help it a bit. And that's what I've been investigating the past few months or years.
If you're a front-end developer looking for remote work, then I recommend G2I, a React and React Native focused hiring platform that will connect you directly with their clients that need your skill set. What makes G2I a unique hiring experience is that they spend the time marketing you to their clients of your choice. G2I is a team of engineers that technically vets you up front. If you pass their vetting, their clients have agreed to skip their initial interview process, saving you time and energy getting your next gig. They take care of all the hard work for you so you can get focused on development. To join G2I, go to g2i.co and apply.
I definitely want to dive into functional programming with TypeScript, but maybe you could start by just sort of, for any listener that's really unfamiliar with the concept, just lay out like functional programming, 101, what is it, why you would do it, that sort of thing.
That's a difficult one. No, I mean, in a way, okay, let me start. Like, we have different paradigms in programming, and most people are probably familiar with object-oriented programming or with procedural programming. And there is actually a third one, which is technically the oldest, and it's called functional programming, which takes function as the core of its operation, and everything is a function. And you compose functions, you create functions, you pass functions as arguments. So that is like a very core of the programming that is connected with another property that is being pure. In functional programming, you usually have a concept of pure functions, meaning that they always return the same result when they are called. Imagine, for example, function random, which always returns a different value. Or maybe you have a function that mutates an array, right? That always changes things. They have side effects. In functional programming, we don't change things. We create new ones. It's called immutable structures. That means you don't change them. You create a new one based on the previous one.
And so correct me, so just so everybody is aware, my knowledge of functional programming is like very, very small, right? I know sort of the high level concepts, but I'm definitely no expert here. So correct me if I'm wrong, but JavaScript is not like a functional programming language per se, but it supports, because I know like the whole functions are a first class citizen in JavaScript. Am I characterizing that mostly correctly?
Yes, I mean, that's true. Like there are languages which are purely functional, like to name a few, it's like Haskell or Clojure. These are only functional, and it's impossible to write in another way. With JavaScript, we usually talk about it as a multi-paradigm language, meaning it supports all and none in a way. So, yes, you said, because it supports functions as first-class citizens, and you can write pure functions in JavaScript. There's nothing stopping you from treating JavaScript as a functional language. But also, JavaScript supports objects. It has it's not object-oriented because, it doesn't have Java, it doesn't have classes. It has prototypal inheritance. But you can combine these approaches, and that's where JavaScript is very powerful. So first, JavaScript is the most used language in the world, and you can combine approaches.
Yeah, it makes sense, because I know that, and we were chatting about this somewhat before, that when it comes to functional programming, I feel like there are some people that sort of casually talk about the benefits, and then there's a group of people that are super totally hardcore into it. Like, functional programming is all they do. They hand out pamphlets at conferences. They really go all in on this. So yeah. Do you you have that experience as well? Is that not just me?
Yeah, definitely. I'm not a hardcore programmer or functional programmer. I know these people, and it's nice in a way, and I kind of admire them, because this world of functional programming is, I think the pure is not just the concept in the functional programming, but it's also how it feels when you write something which is purely functional, it feels like this pristine, pure, and it's like very clean. And I understand that it feels very good to achieve that. I myself have a background in mathematics. And by the way, my advisor for the thesis was one of the best in category theory, and functional programming is very closely related to category theory. I really wish I at least had a class on that, because it would help me with functional programming. But in a way, functional programming can be very mathematical in the way that people want to be precise and they want to prove things, and they want to have one way of like proving things. So it can feel overwhelming, and truly is. I mean, there are so many concepts in there. There are so many new words, like, I mean, monads and functors and all of these, and they just sound so weird to people who are not used to them. And I was one of them just a few years ago.
Yeah, and so before we get into like the specifics here, I'd be curious, like, what have you seen? Like, what are some of the benefits of taking this approach? Like, to someone that hasn't used any of this stuff before, I'd be curious what sort of things why you would encourage someone to sort of take the plunge and learn some of these concepts and this approach, because like you said, it is really a different paradigm. So there is going to be some work to get up to speed with this sort of thing.
I would say there are many reasons. Well, one I would pick up is we are on a React Roundup podcast. So I assume most of the people who listen to us know React. And actually React and many things that Facebook has been creating come from a functional approach or like a functional background. So React itself is, I mean, I don't know the exact name for it, but it builds on functional principles. The same is true for example, Redux, like one of the most used state libraries. And that's actually just a simple, like a reducer in a way, which comes from functional programming. It's like, it's very cool. Like in a way, Redux is just, I think I saw it implemented in 29 lines as some blog post. Like it's very simple, but it's very powerful. And I feel that's the true things for most of the functional programming ways. It's about reusability. It's about creating functions that are small, they do one thing and they do it when, and then you compose them in a way and you understand each of the pieces and you understand the whole thing as well. That being said, it can get complicated, especially when you introduce these new terms and you are unfamiliar with them.
Yeah, no, that's a good point. I do feel like React has a lot of, like you said, like use reducer sort of thing. I think most React developers be familiar with what that is, or even just the act of React makes pretty heavy use of just passing around functions and chaining functions, and even just that sort of thing is sort of functional in nature as well. Actually,
I mean, this one term I know. So hooks, which many people had problems with, or like they were surprised they were introduced. This is something called algebraic effects in functional programming. So nice. I'm just saying that there is a whole world around this, and especially the Haskell community is very strict about it. And many of these ideas come from Haskell, either directly or indirectly.
So if you want to sound cool at your office, just go into your code base and say like, "Oh, I see the use of your algebraic effects there." Like, "Oh, that's right, you call them hooks still." That's
yeah.
Not very fancy.
You can go so much deeper. There's this like book which is targeted to programmers, and it explains category theory, and then you can come and then you can throw these functors and semi-monoids and whatever all around. I don't understand that, honestly, sometimes. Like I do some of those right now, but I get lost in them so easily.
Gotcha. So another question I have then too is, you have some expertise here with TypeScript. And I'm curious how, like, where does TypeScript sort of fit into this? How does functional code in like TypeScript different from JavaScript? I'm sort of curious how that fits in.
I would start a little bit broader, because TypeScript isn't my first choice for writing applications in let's say JavaScript. What I mean by that back in the days, well, just a few years back, I started with Elm, and Elm is again functional language. It is, I would say, hugely inspired by a Haskell, but it's purely for front end. It's only for web applications. And Evan Chaplitsky, who created the language, I think the language is really nice because it gives you these rails, and it's difficult to do something wrong. It has the best error messages I've seen, meaning a compiler error messages, and it's just like pure in the sense I was talking. Like it feels very nice to build something in that. And I was a big fan of Elm for a long time. And I kind of like it. I still think it's a really good language. However, I kind of stopped believing it will make the jump. It will not become mainstream. For a while, I was organizing Elm meetup in Berlin, and there was a nice community of people, and it was interesting ideas. And I think I became better React developer because of Elm, but I just kind of lost faith that it will make it in a way. And I moved to another language, which was ReasonML. And I thought, because it's backed by Facebook and all of that stuff, I thought that's the thing that will make it. And I think that you spoke with Patrick a few episodes back, and he's a nice guy from Vienna. So if you want to know more about ReasonML, listen to that episode. But I think the same thing happened. And I was just like, okay, it's not going to make it. So let's just do JavaScript. And then I went with flow type for type checking, which again, from Facebook. And I would say it's more functional than TypeScript, because TypeScript is designed by the same person who created C#. And Microsoft's been great at classic object-oriented languages. So you can still see this inspiration. So it wasn't my first choice, but then everything else kind of died. Like TypeScript won. Like it now occupies it. It's like, as I said, it's the most used language. So what I'm trying to do now is to find a way how to use this most used language in a way I like it.
Yeah, it makes sense. And I definitely, it's funny too that I guess, would you still, like, if you could have your way, and if let's say Elm was just natively in the browser, you'd prefer to write code that way? JavaScript's sort of like I think it's not uncommon, because so many people come to JavaScript because it's everywhere. So, yeah. I mean, at a certain point, if you want a job, if you want to just write apps that people are actually going to use, it sort of becomes a necessary evil, or whatever the case may be. It's just where you happen to end up out of necessity.
Yeah, I mean, I agree. I really like Elm. I think it's a well-designed language. And I think the problems is that, like, maybe it will make it, like there's still chance, but maybe it's too different for most people. So now, by the way, I work at Klarna, which is a Swedish company. And the core of Klarna was written in Erlang, because, Ericsson created Erlang and stuff like that. But what I didn't know before I joined is that their original versions of runtime were written in Elm, because functional programming is strong at Klarna. But they had to stop that because they couldn't find people. Like it became like a real problem to find people who can run Elm at this scale. And of course, for example, Richard Feldman, who, by the way, recently published a book about Elm, says that it's easy to bring people to Elm, and I agree with that. But if you would like to grow and you would like to double or triple number of developers you have in a year, it's just not scalable. You cannot find the people, you cannot find the coaches. So, but yeah, I would love to have Elm.
Yeah, no, I can sympathize with that too, because I've done years of Java development. I've written PHP code. I've written, I've probably somewhat passable in 4 or 5 different languages. None of those languages are Erlang. None of those languages are Elm, right? And I would never apply for a job that mentioned one of those things, because it's the sort of thing that feels, for the same reason that even functional programming in JavaScript feels like a bit overwhelming. Going to a completely other language that embraces that fully, just in my head at least, I know yeah, if I dedicated myself, I'm sure it's not that bad. But in my head, it seems like such a huge task.
It's true. On the other hand, I think it's twofold. And when I was looking for a new job, I actually searched for companies writing in Elm. That was one of the first things I put in the search bar in that job advertising. And it would have been a great competitive advantage if they used this language I liked. And on the similar note, I think that if you get people who know this language, they come with a certain mindset, which I think is beneficial. With JavaScript, there's so many variants of JavaScript, and people come from so many backgrounds. And I mean, not backgrounds but I mean programming backgrounds, like how they write, how they like to work. But usually with Elm, these people are, I would say, curious by default. And they share many of the ideas you would have. So that's also beneficial if you can get them.
Yeah, and there's some React sort of parallels here, because one of the things that I've written both Angular code and React code, and I have things I like and dislike about both. But one of the things that I liked about Angular is it enforced a certain amount of consistency. So you could jump into an Angular app and know sort of how things worked and how things functioned and how things were structured. And React, one of the benefits is you can kind of do anything. You can do whatever you want in a lot of cases. Like there's not a whole lot of hard and fast rules, but there's obvious benefits to that. But the downside is that you can get stuck on these. Which tool should I use for this? Which router am I going to use? Which CSS implementation am I going to use? And it can make a big hassle, a source of time sink, that sort of thing. Learning curve for bringing in new people. They might not know some React library you're using, that sort of thing as well. So I can see the benefits of, even at the language level, having a certain consistency built into things.
Yep.
So with that background aside, TypeScript, and I'm going to take a guess here because I know I also have mixed feelings about TypeScript, and I like a lot of what it does. But one thing I fight against is sometimes the type system becomes more cumbersome than useful. Like there's certain times where it's like I know what I'm doing, but then I have to do some work to tell the compiler what I'm doing. And I'm going to take a guess. You can tell me if I'm wrong. That's actually going to be one of the tricky things of dealing with functional programming in TypeScript as well.
That's interesting. I don't think so. Not necessarily. I think that in a way it can make things easier because I think it's stricter. Like it doesn't allow you that many things. And therefore, it makes it easier for the compiler to infer types, and you don't have to type that many things. However, and that's true, once you hit something, it can be very difficult to debug that. So yes and no.
Okay. So I know you have some libraries and such you've worked with here. I guess if you're giving developers sort of steps of, you're doing TypeScript, you want to do functional programming, where do you recommend people, where do you go, what do you do, that sort of thing?
I think in a way you don't need anything. You can use just the JavaScript or the JavaScript in TypeScript, like the built-in things, because for example, when you use some array methods like filter, map, reduce, these are very typical functional patterns. So you can do many of these things just with pure JavaScript. And I very often do that. And yeah, you can do that like this. However, especially people who know other functional languages, the Elm or Haskell, these languages have built-in structures that make it much easier to work with code. And here I'm talking, for example, about option, sometimes called maybe type, meaning it either has some value or it doesn't have a value. So instead of using, for example, null to represent missing value, you have a very specific value saying there is nothing here or there is something. And then you can do only transformations when there is something. So for example, there is maybe a number and then you want to double it. You only double it if it's there. If it's not there, you still keep the nothing, let's say.
Gotcha. I'm just trying to picture that in my head. So is it like an actual, in the case you were using TypeScript, would it actually be a TypeScript type? Would you declare something as a maybe, essentially?
I mean, maybe you can imagine it and that's how you can even that's how it's implemented, is that it's an object which has one special property. Let's call it I think it's called tag. And that is either string none or string sum. And if it has string sum, it also has another property called value, where you have the value. And then you have a set of utilities that know this type exists and was the shape. For example, the method I was talking about is called map. So if there is something, meaning check what is the tag. If it's sum, apply the transformation. If not, don't apply it. Gotcha.
So basically, it's in a sense you're cleaning up your code a little bit, because I've probably written thousands of if this exists, and then even those if those exist checks are kind of hairy because JavaScript does null, undefined, truthy values gets hairy.
Yeah, and I think that's where we get to the core why you should use functional programming. And I mean, especially with this library I'm talking about, it's called fpts, functional programming TypeScript, by Giulio Canti. He's I think Italian programmer, and he builds a set of libraries. It's a family of libraries, and I think we can link them. And it's really, really interesting. And they implement so many of these helper methods. I mean, I was talking about the option, but it has, 30 or 40 of them. I'm not using all of them. What I think is where is the core of this is that you think about errors in a different way. Because I grew up in thinking errors are something bad. For me, errors meant mistakes. And if my code produces errors, I made a mistake as a programmer. And it took me some time to realize that's not the case. Errors are part of the code. Like some things are meant to fail, meaning if you have a validation, that's the most common example, like you want it to fail, like in certain cases. It should, it's expected output. And functional programming, if you treat it well, treats errors as data. It makes you treat them like as a normal case, and it makes you deal with that. Meaning you cannot ignore it. You cannot like bubble it to the top and have the error shown. No, you have to deal with it. Like if you have something that can fail, you need to say what's going to happen. For example, with the validation, you have to define a function, what happens when it's successful and what happens when it's not.
Gotcha. Yeah, no, I'm very much, and I don't even think like that error handling thing, it's broader than just JavaScript too, because I have nightmares from my Java days of error handling in Java, where because error handling in strictly typed languages is absolute horror, because you have to, there's the bubbling you describe, and it's just a nightmare. And so lots of times developers just won't do it because it's such a hassle, and it's something that is quote unquote not supposed to happen, right? Errors aren't supposed to happen. So,
and if you look at TypeScript, like I think it's even impossible to type a function that is expected to throw errors. Like you can type the return type, but I don't think that there's a way you can define errors it will throw. Like if it can throw, I don't know, type error or anything. Like that's not, the TypeScript doesn't have a way to do that. I mean, maybe you can do some workaround, but by default, it doesn't think about that.
Yeah, because TypeScript almost is designed to keep you from doing that, right? Like that's sort of the point. You're not supposed to get errors. You're using TypeScript.
Yeah. which is dangerous because if you believe TypeScript too much, it can bite you. Like TypeScript isn't that safe. Like, and that's one of my biggest reservations against or to TypeScript is that it's very easy to break it. Like one of the easiest things is you declare an array of, let's say, strings, and you access a variable or like an element there, and it thinks it's a string. But what if it's not there? What if you access I don't know, 1,000th element and it only has 5, right? You get undefined, but you don't know about it. TypeScript doesn't tell you. So again, like in FP, we have ways how you can access it, and then every time you access an element in an array, it says maybe it's undefined, and you have to deal with the case when it's undefined, which I understand can feel a little bit like too much work, and people want to focus on, like they say, oh yeah, I know it's going to be there, but then you either have to type it in a way that you know it's there and the type system knows it as well, or you have to deal with the possibility it's not there.
Hey folks, are you trying to figure out how to stay current with React Native? Maybe you heard the Chain React conference was canceled and you're a little bit sad about that. Well, I borrowed their dates and I'm doing an online conference. So if you want to come and learn from the best of the best from React Native, then come do it. We have people like Christopher Shadow from Facebook. He's going to come and he's going to talk to us and answer questions about the origins of React Native. We're also going to have Gant Laborde from Infinite Red and several of the panelists and past panelists from React Native Radio. So come check it out at reactnativeremoteconf.com.
So when you say you have to define like sort of the error case, is it like a TypeScript compiler thing is going to force you to implement like a property? Like what is that? Just to help me paint a picture, what does it look like in actual syntax? Is there like an error property you have to define with a function or something like that?
I think let's use promises as an example because many people know it. And when you have a promise, it can be eventually in 2 states. It's either fulfilled or rejected. And I think it's very common for people not to care about the rejected state, and they only focus on the fulfilled. And imagine that. And then another thing is that you have the then method, and it has actually 2 arguments. The first argument is when it's fulfilled, and the second argument is when it's rejected, which many people don't implement. So imagine that both of these were required to be implemented by so the TypeScript would force you to implement both of those functions. That's what I'm talking about. You have to take care about the failing case.
Gotcha. And so that's the sort of thing that like, and when you say forced to, TypeScript itself won't do that. That's more where like the fpts comes in, right? Because like the certain typing that comes in that's going to force you to adhere to those sorts of things.
Yeah. And I mean, again, forced means you will get a compiler error. So, I mean, you can still, I guess, ignore it or whatever, but that's on your behalf. Yes. By default, for example, the promise I talked about, they don't have this condition. So you can introduce new structures, which will be like the promise, or they will do different things, which will have these kind of restrictions. And then you will have these utilities type in a way that again, point you in the right direction.
So if I were interested in the FPTS, if I wanted to sort of dive into this, what would you recommend sort of as like a logical path forward, right? Because to be honest, I looked over a bit before this, the documentation, and my brain melted just a little bit because
I know.
There is a lot there.
Yeah, and it's bad. Like, I mean, okay, so this is exactly the case when I think it's hardcore. Like, it has all the information you probably need, but it's not in a format you can understand unless you know things. So I totally understand that people who are very deep into that, and for example, Giulio Canti, the creator, can look at it and they know what there is. For me, I still have, when I go to the documentation, and I try to avoid that, it takes me so much time to actually understand what things means, because there is my favorite example. Like, you can have a structure called apply, and then it has like a paragraph, like, I don't know, like, let's say 7 sentences, which don't give me much information. And the last one says, apply represents a strong lex semi-monoidal end-functor. And I would stop reading, like, immediately.
Yeah, so, I mean, duh, everybody knows that, right?
So, I mean, and my first reaction would be, I'm not smart enough to understand this. So the first thing you should not do, you should not look at documentation for some time. I think the best way to learn FPTS is through examples. There is a, let's say, nice, but also a little bit hardcore series on dev.to by Giulio Canti about FPTS, which is okay. But if you have a functional background, it will give you good instruction. If you don't have that, I think it's very difficult. And I mean, I've struggled with that. And it took me a lot of experimenting because I was dedicated to learn that. But I think as of now, there's no good introduction to that. And I mean, in a way, I would like to change that. I would like to talk about the conferences and show the benefits. And I think we are waiting for someone to write a tutorial or maybe even an ebook that will really explain it to people who don't want to write functional programming, but what they want to get the benefits.
So I'm curious then, maybe if we even take a step back, because it sounds like you came to functional programming if you came to FPTS because you really liked functional programming and you were trying to bring those things into a TypeScript world, but you already had the background. So I'm curious, what sort of brought you, like if we take a step back, what brought you into the functional programming camp sort of in the first place back in the day, like even back when you went into Elm and such? Like what sold you on the technique?
Yeah, there's a very easy answer to that, and it's very fitting because it was React, in fact. So
interesting.
A long time ago, I was working with Angular 1, and to be honest, I like that because I'm not sure it's known, but there are many, like in the original Angular team, there were people from I think Slovakia, and I'm from the Czech Republic, and I was fortunate enough that one of my colleagues was a friend with one of those core creators of Angular. So in our company, we tried Angular before, let's say, it was big. I mean, and that actually was for me the first time I came into JavaScript world as well, because before that, which is also interesting, I was focused on CSS. And when I say focus, I mean, like my goal was to become a CSS working group member in W3C. That didn't happen. But I mean, I think it gave me this thing when I can focus on things. So I didn't do all the languages. I didn't do PHP and Java and JavaScript and I don't know what else. I kind of focused on that. And I think it was a good decision for me. And then I was in this company and they were writing with this cool new framework called Angular. And I came in there and I learned my JavaScript there. And then React came and it totally rocked my world. Like, I was so surprised. I was coming to these meetups in Prague and there were people talking about that. And I liked that. And I'm not even sure how it happened, but I was immediately told that React is based on functional principles. And I started to be interested in them. And that's how I came to functional programming.
And what were your next steps from there? Like what I'm getting at is I'm curious, like what sort of learning material. So if someone wants to just get involved more with functional programming, language agnostic, or maybe even something web-centric, what sort of resources, guides, tutorials, videos, what would you recommend that's out there?
I think for a person who knows React, I would say it's really good to start, for example, looking at Redux and see how it internally works and why there are like constraints that they are there. Maybe try to re-implement that. I think that gives you the very gist of why things work like that. And then we talked about it. I really like Elm. I think that Elm is very friendly to beginners. And I know I said it's not maybe not going to make it in a big world, but I still think it's really awesome language to play with and to learn from. And yeah, so in a way, I would say it's very, very good to start with Elm. And they can shield you from this hardcore functional programming stuff. They can really focus on what is important.
Gotcha. Yeah, I'm curious. I think you mentioned this before, but this is just a random question. But who are the people behind Elm? I'm just sort of curious where the language came from, because I'm totally naive here.
Yeah, so Elm was developed as it's Ivan Chaplitsky created his dissertation, I think, or master thesis, one of those, at the university in, I think, Budapest. And it was about functional reactive programming. He created this language. And I know that there's a company, I think it's called No Red Inc., where now Evan works, and it has like this group of people who work there. But of course, like the community is now everywhere. And I think for many Haskell people, this is like the best way to get into front end. So also many people from Haskell came there.
Are there any sort of like, especially for these functional languages, are there like certain niche types of like, what types of apps are the best to build with these? Or are they just general purpose enough that you can build anything? Are there certain use cases that work better than others?
Yeah, I think most people will not like to hear this, I guess. But I would say business critical systems are really suited for functional programming. And I think that's because I talk about the strictness and purity, which is both there. And I think it's when you have a functional code, people say it's easy to reason about it, meaning you can get into it and you can follow what is happening and where transformations happen. And because you are, as I said, sometimes forced to acknowledge the errors, it's error prone, right? It's not error prone, whatever. You can get less errors, right?
Yeah, and it's interesting too. I've just been sort of perusing around like the websites, and a lot of these languages, like I looked over Elm's site, and I just brought up Erlang's as well. They talk about this. One of their leading features is just performance, right?
Yeah.
Like speed.
And this is a nice arc, because when you look at Elm, one of the biggest advantages they talk about is that you can get 0 runtime exceptions on production. Like the company that uses Elm, the Red Inc., I think that Richard Feldman is just like, I would say, evangelist for Elm. I think he said that they had one runtime exception, and it was a mistake in the Elm compiler. But other than that, there's 0, like no undefined is not a function. And why I say it's a nice arc, because now we can go back to the fpts, and one of the things I talked about at React Day Berlin, which is called Iots. It's one of the family of the libraries, which is about runtime types.
So hold on, explain this to me a little simpler. So Iots, where does this? There's enough acronyms floating around.
Yeah.
So Iots is what exactly again?
It's input output in TypeScript. So I think that I'm not sure how many, but there are many of these libraries. I think that the fpts is a core, and built on top of this are some other libraries. And Iots, I think, is very interesting. And maybe when we talked about starting, I would say Iots is maybe the best one to start with this fpts world. So what Iots is? So in functional programming, you have this pure internal state. Like your code inside is known, you have all the types, you know what is happening. And then you have the ugly world around. Like it can be the user inputting something, it can be accepting API requests or whatever. Like something comes from somewhere and you cannot be sure what it is. And that's why you have this input-output layer, which, let's say, validates it. It makes it that it's pure in the internals, and it makes sure that everything is as it should be.
And so for runtime errors, you're basically saying like once the code, like you pass all your compiler checks and then something can go wrong, right? And I think what fascinates me is I remember that back in the day, I remember the rise of like JavaScript error checkers, or I should say like error loggers, like these, like, and I think there's whole services around this now where basically you add this to your web page and it like collects any like uncaught JavaScript errors and like reports them, logs them somewhere in a list. And I remember a company I was working at, this was probably like, I don't know, almost 10 years ago now, but we decided like, oh, let's just turn one of these on in production and just see what happens. And like, you see the like absolute gargantuan mess of errors that JavaScript spits out that like, even like some of these were like, where in the world are these things even coming from? It's because like just the loose nature of JavaScript means that like so many things they just slip through the cracks when you don't even know how they're doing it.
Yeah, that's exactly it. And in a way, TypeScript doesn't help totally. So maybe we can look into that. So TypeScript is a static type checker. What it means is that you have your source code and you can run some checks on this source code. But once you compile this source code to the production JavaScript, all of the type definitions are lost. Like it's like in the end, it's JavaScript. It has no types. You don't know things. And it was a conscious decision by the TypeScript team not to build runtime checks of any kind. So because it would be almost impossible. What it means, for example, you define a function that receives, I don't know, name, which is a string, but it can be called by anything in the JavaScript world. And if you would like to make sure it's a string, every function that accepts string would have to have like a check, like, I don't know, if type of name is string. And these can be very complicated for some complicated structures. So you would have to do it for each and every function, even though it was probably already called by another. So it's very difficult to do that. And I mean, for dynamic language like JavaScript, it's almost impossible. What you can do, and that's when Iots comes in, is you can define a way that you know what is come in a runtime. And I mean, let me go through that, because a good example is an email address. Imagine you would like to have a function that receives an email because you parse it or whatever, but you don't want to check the format of it. You kind of want to know it's an email. What Iots does is that it helps you define this type, saying it's email, but the only way how to produce a value of this type is that it has to go through validation. So what you kind of get is that if you say, I want this function receives email, you know it has at least once passed validation. And that's what you can do in static time. You can say, okay, has this ever went through function of validate? And if yes, you know it's going to be an email. So that's what, in very, very broad terms, Iots does.
So off the top of my head, I could see one complaint being that your code gets more verbose or like clunky. Is that going to be the case, or?
I don't think so. I think so. I have here one book. It's called Domain Modeling Made Functional. And I really like this book because DDD, domain-driven design, is, I would say, very nice approach. And again, the gist of that is you first define entities you work with, and then you define how these interact. And you can use types to capture these entities. And with Iots, I think you can easily capture these, let's call it business types, like email or even unique email or things like that. And then you know how your function exists in your domain, like what it does. Because if you have a function that receives user string, it's not very clear, like string, what does it mean? But if you know it's like, let's say, activated user, you already know so much about the flow and everything. And with Iots, you can define these, they're called branded types, which is like specially defined, validated values.
Just in terms of like the verbosity of the code, is it more verbose compared to like if you were doing this in pure like Elm or Erlang? Like, do you have to fight against like? I'm sort of curious because like, so in my head I'm thinking, so TypeScript, all of this is based around types, but like Elm and Erlang, like, is there a similar typing sort of structure? Is TypeScript like? I'm asking this to someone like totally naive to the raw functional world.
Yeah, to be honest, I don't know. I think that the type systems are different. They were also designed with a different purpose. And maybe, I mean, in a way, of course, the fpts is going to be a little bit more cumbersome because it's not native to TypeScript or JavaScript. So on the other hand, they are pure TypeScript. What I mean by that is that I could create a separate implementation of the compiler of TypeScript, which supports this. But then it would create this really weird, like, I mean, it's like splitting, like forking the TypeScript, and you don't want to do that. So what I really like is that fpts is just TypeScript. Like, you can write it yourself if you know how to do that, but it gives you the utilities and patterns how to work with stuff. So it's pure TypeScript. There's no magic extra. And in a way, you could have written it yourself. So it's beautiful in this sense. And yes, because it's added, it can add some more verbosity.
Gotcha. So just take a step back, because I want to kind of like summarize things for our listeners, right? Like depending on where they're coming from, specific steps. So I'll lay out like the notes I've taken so far, and you can then just add on anything you've got. So I think your recommendations from before were, if I'm like a web developer that's sort of casually interested in this, I think your first recommendation was getting familiar with React and certain things from the React world, like Redux, that are more functional in nature. You recommended playing with languages like Elm, just sort of experimenting, seeing what you think, that sort of thing. And then I guess from there, would you say like if you're into TypeScript, would fpts be the place to like start? You said like learning by example, diving into that and seeing like how you could take some of those comp sets from TypeScript. Is that a good summation? Is there anything else you'd sort of add to that? Any other recommendations?
I do have one recommendation. I mean, so I agree with that. I think that's good. And maybe what I wanted to talk about is a use case for fpts and iots me and my friend did. And I think that maybe it could be a good start to exploring, because it's for React. We kind of created a hook. It's called useForm. And what you can do is that to this hook, you basically pass, I think, two things. One is, we call it the codec, which means like the type created in IOTS, where you say, for example, there should be an email, which should be like type email. There should be a name, which is non-empty string of maximum 50 characters. And this is like, creates this business logic, this like, you know what it is. The second argument is, I think, is the initial state. And then you can create a form which can get validated. And what is beautiful about this is it's all typed. So for example, when I receive errors, I know what kind of errors can be there. Like I know what fields are there. But because we want to internationalize things, if you would like to translate these errors, you need to provide a mapping of all the types, right? Like, I mean, not email, you need to write some message saying this is not a valid email. And because TypeScript understands the whole structure, it knows if you haven't translated something. And when I first saw it, it was a little bit mind-blowing because, for example, you forgot, like you say email, but email has to be non-empty. And so you have to have two things, like it shouldn't be empty and it should be an email, and you have to provide these translations. Plus, and then, I mean, that's where it's kind of very handy, is that these are client errors. So on client, you can check that an email is not a valid email, let's say. But how can you make sure you don't have it already in your database? Like if it's a sign-up form, how do you know this user doesn't already exist? You can't know that on front end. But on front end, you can prepare for it and you can say it should be a unique email. You write how you define it. And then where the backend returns the errors, you kind of know, again, it's preparing for this. You have the translation for this scenario. And I mean, maybe it sounds a little bit complicated, but I think in the essence is, again, I know what's going to happen and I'm not surprised.
Yeah, it's sort of a paradigm shift because I think very few people would think to call that like unique email, right? You just write email, it's a string, and get on with your day, but you wouldn't prepare for the eventuality that accounting for that state coming from the back end sort of thing. Yeah. So it's interesting.
Yeah. And of course, like it's TypeScript, meaning it's full stack. I can use maybe even the same types on front end and back end, and I can use, that's what I use it for in my work, is to guard the backend APIs so the bodies have the correct shape. But you can use it on the front end as well, and you can share these types. And I'm coming back to the DDD. These types are your business types. Like that's your domain. They exist there, so they should exist in both front end and back end.
Gotcha. Is this an example that's online, like that some other people can look into?
Yes. We can post the link there. We have the example there on Code Sandbox.
We'll make sure that gets into the show notes. And then at this point, is there anything else that you want listeners to know about? Any other topics that we haven't covered that you'd like to jump into before we wrap up?
Yeah, one thing, and it's like not to be afraid of functional programming. And I know I was, and I still a bit am. What helped me was this talk I heard somewhere when this presenter talks about like all the different terms. I was talking about the functional programming, like monad and functors, and then said, yeah, but it's only, you don't know them. You weren't exposed to them. That's why they feel so weird. But if you look at for example, objective-oriented programming, and you have inheritance and you have singleton. All of these terms also sound scary, but they are not scary to you because you've been exposed to them and you know them. So my last message would be not to be afraid, not to get discouraged by these terms, not to get discouraged by people who are hardcore. And I think that the functional programming has a lot of offer, and you can get only the important parts.
It's a good note to end on. And I feel like you're almost looking at me right in the face, because I'm definitely somebody that's totally guilty of that, right? That's just letting the complexity that I think that it has to sort of intimidate me from diving in a little bit deeper.
Back when functional programming was making its resurgence, I found it really interesting that a lot of people were moving over there, and it almost felt like it was on hype. And I didn't really understand the power of functional programming until I learned Elixir. Elixir is a functional programming language. It's built on the Erlang virtual machine, and it really does some interesting things and makes you build apps in a different way. But what's really fascinating about it is the speed of the applications, the ability to distribute work easily, and just how it manages the functional programming and all of the nice things about it so that you don't have to worry about side effects and a lot of the other things that come out of functional programming. Plus, pattern matching in Elixir is a killer feature. If you're looking for a new language that you want to learn that is going to make a difference for you and give you the opportunity to challenge some of your thinking and find a new way of doing it, Elixir is a great way to go. And we have a podcast now on Elixir called Elixir Mix, and you can find that at elixirmix.com.
So on that note, why don't we jump into the picks? Are you familiar with the concept of picks before? Do you have a few?
I am. Yeah.
All right. Why don't you go ahead and start us off? What picks do you have for us today?
Oh, I have this very special thing I discovered a month ago, maybe even less, during my time, in being home, not going to work. And I think I'm more tired after work now. So I need something to relax. And I discovered this YouTube channel. It's called Cracking the Cryptic. And it's two guys who are Sudoku champions. They solve Sudokus. And I mean, they solve really difficult Sudokus with some extra rules. And then these videos can be easily 30, 40 minutes. And it's just mesmerizing for me to watch someone logically, put another number in the grid. And I feel like it's like a relax, but also I still have to think about that. It's not just that passive. So I would recommend you. And they do one video every day, or actually 2 videos every day.
You have to check this out. My wife is crazy good at Sudoku, so I think she'd really appreciate this as well, because we sit down and do them, and she just can blitz through them, and not me. So it's interesting. Any other picks?
Well, I mean, the books I thought about, but that's it.
Gotcha. So I have one pick today that is, I've picked up an Oculus Quest, sort of another it's quarantine. So what are you going to do? So why not pick up some VR goggles? And I've always been a VR sort of naysayer sort of deal. I didn't quite totally understand the hype, but I'm now totally bought in because it's surprisingly how much just putting on the glasses and going through the tutorial can really suck you in to the world, and you sort of completely lose your surroundings, lose a sense of where you're at. So I've been going through and doing that. And another pick I'll have is AltSpace VR, which is a platform for basically holding online meetings and gatherings in a VR world. And it's something, so I work for a company called Progress, and we do events. And so we're exploring the idea of maybe we could do, online events are kind of becoming a little bit monotonous. They can't really truly replicate the true conference experience. So this is something that we're sort of exploring around, and it's kind of an interesting platform and something that we're going to dive into a little bit deeper. So these are my picks. All right. Well, Robin, it was awesome talking to you today. To wrap us up, why don't you let us know, where can people find you if they want to, contact you online, follow all the great things you're doing?
Yeah, I was fortunate enough to grab handlers at almost any social media with my name. So it's almost always at Robin Pokorny. I'm active at Twitter, I would say mostly. I even tried recording some JavaScript videos on YouTube, but yeah, it's difficult. And if you are in Berlin, I am one of the co-organizers of React Berlin. So once we get meetings again, just pop up and we can talk.
Awesome. Well, thanks again for everybody for joining us. Thanks, Robin, for coming with us today. And for everyone, see you next week.
It was a pleasure. Thank you.
Bandwidth for this segment is provided by CacheFly, the world's fastest CDN. Deliver your content fast with CacheFly. Visit CacheFly.com to learn more.